We're going to go ahead and interpret key features of the parabola within the context of some word problems in this. So let's go over a couple of those key features. One of those key features is the x-intercept. So here's an x-intercept because that's where it's crossing the x-axis. Here's another one. So kind of a key to the x-intercept is that the y is 0, right? So that's the x-intercept. And we know that there y equals 0. Now what's interesting about the x-intercept is this is the ending value. So usually we start right here, and I should have started with the y-intercept, which is right here. So we're starting here, and usually if this is time, we don't go back in time. So we start time right here. Starting there, we throw a ball into the air, it goes up in the air, and then it comes, and then boom, it hits the ground or hits the water, whatever the problem is. Usually that ending value is right there. And there's some other context of it, but anything to do with the output equaling 0 would be the x-intercept. This is also the other x-intercept. Let's talk about the y-intercept. We know it's the y-intercept because it crosses the y-axis. And similarly, we know it's the y-intercept because x is 0. The independent variable is 0. And this is the starting value. How high was the ball before he threw it? What was the height of the rocket before it launched? That kind of stuff. Then last, we have our vertex, which is our minimum or max. Now you're going to answer, this is the one that gets the most confusion. Should I answer with the x or the y value? You're going to answer with the x if the question is, usually when the question is asking when or where. When did the maximum occur, or where did the maximum occur? And then you'll answer with the y if they're saying what is the maximum. So those are kind of the key things there. That puts it all together. And as you go through more and more problems, you really need to get this down because later on when we go through the different forms of quadratics, we're going to keep revisiting these same word problems. So here we go. Plot the point on the graph of f that corresponds to when the ball hit the ground. So Mia kicked the football. The function f models the height of the ball above the ground as a function of time after Mia kicked it. So right here, the ball starts on the ground. She kicks it, goes up into the air. We're going to put this point when it hits the ground. So it hits the ground right here. So that's not too bad. Let's look at this one. Plot the point that corresponds to the shop's net worth when he opens it. So when he opened it is the starting value, which is the y-intercept. So that would go right here. I don't need to read the rest of this. You can already tell. This is the initial value, y-intercept. Hitting the ground, that's telling us x-intercept. Plot the point on the graph of f that corresponds to the time when the hovercraft reached the maximum. So it's not asking for the maximum, it's asking when did the maximum occur. So here's the maximum. Now I'm kind of curious if they just want us to plot it right here. I'm going to have to try this assignment. And you might have to try it once, but I would just place it on the maximum. But later on, if they were asking us the x or the y value, then you would have to, just answer with that x value of 1. Then last, plot a point on the graph that corresponds to the ball's maximum height. So that would be the y value if they're asking the x or y. You would answer with the 80, which occurs when x is 4. But that would be the maximum height. So once again, the only thing I'm unsure is they're saying plot the point on the graph of f. So it has to be plotted on the graph of f. F is this blue curve, so it would be placed up here. You wouldn't put it down here because that's not on the blue curve f.